Now let's talk about bearings. If you see this north 30 degrees east, what does that mean? How do we draw it? So first, let's write the directions. So this is north, south, east, west. A bearing is an acute angle that's measured relative to the north-south line. So you should always start with this line. So starting with the line that is facing towards the north, we need to travel 30 degrees towards the east. And drawing a line from the origin to that point, this will give us the bearing. So if there's an object that's moving at this direction, this line represents where it's going. Let's try another example. Try this one. So let's say if we have the bearing north 20 degrees west, how would you draw it? So north, east, south, west. So starting with the north-south line, we need to travel 20 degrees towards the west. So the bearing is represented by the green line. The object is moving in that direction. Draw this one. South 50 degrees west. Feel free to pause the video. So we have north, south, east, west. So we're going to start with the south line. And then we're going to travel 50 degrees from that line towards the west. So the bearing is in this direction. And here's the angle of 50 degrees. So that's how you can draw it. But now let's say if you're given the angle, let's say this angle is 40. What is the bearing? Let's say the object is moving in the direction of the red line. So we have east, south, west, north. What's the answer? Now this angle is 50. So should we say south 40 degrees east, or should we say east 50 degrees south? Are both answers correct, or should we use one over the other? Because here you're going east relative to the south line, and here you're traveling south relative to the east line. Now by definition, bearings are measured from the north-south line. So this first letter should be N or S. It shouldn't be E or W. Therefore, we're going to get rid of this answer. So it's south 40 degrees east. So you're starting from the south line and you're traveling east. So make sure you're aware of that. Let's try another example. So let's say if an object is moving in this direction and you're given an angle of 20 degrees. What is the bearing? Now, we shouldn't use the 20-degree angle. You want to use the angle between the direction line, or if you want to call it the direction vector, and the north-south line. The 20 is between the direction vector and the east line, which we don't want. So this angle has to be 90 minus 20, which is 70. Because the angle between the north-east lines is always 90. So this is the angle that we need to use. So it's going to be north 70 degrees east. So relative to the north line, you're traveling 70 degrees towards the east. Let's work on another example. Find the bearing. So go ahead and try this problem. So we shouldn't use this angle because it's not adjacent to the north-south line. We need to use this angle, 60 degrees. So relative to the south line, we need to travel 60 degrees west to get to the red direction vector. So it's going to be south, 60 degrees, west. That's the answer. So this first number, first letter should be north or south. And then the second letter should either be east or west. And if you keep that in mind, there's no reason why you should get this wrong. Let's work on some word problems. A car leaves city XYZ at a bearing of north 40 degrees east and travels in a straight line for 300 miles. How many miles north and how many miles east has the car traveled from the city? So let's say this is city XYZ. So this is north, south, east, west. The car is traveling in the northeast direction. So it's going this way. And the bearing is north 40 degrees east. So starting from the north line, we need to travel 40 degrees east, which means this angle is 50. Now we want to find out how far east he traveled and how far north. So if we draw a triangle, this is 50 degrees and he traveled for a distance of 300 miles. We need to find x, which is how far he traveled east, and y, which tells us how far he traveled north. So what function should we use to find y? We have the hypotenuse, and y is the opposite side relative to the angle 50. X is the adjacent side. So to find y, we need to use sine. Sine of 50 degrees is equal to the opposite side y divided by the hypotenuse. So 300 times sine 50 is equal to y. We got to multiply both sides by 300 to isolate y. So now let's multiply those two values, 300 sine 50. So y is equal to about 229.8 miles. So that's how far north the car traveled relative to city XYZ. Now let's see how many miles it traveled east. We need to find x. Cosine 50 is equal to the adjacent side x divided by the hypotenuse. So we got to multiply both sides by 300 again. So 300 cosine 50 is equal to x. And so that's going to be about 192.8 miles. So that's how far he traveled east relative to city XYZ. Number 2. A boat is 12 miles west and 15 miles south of an island. What bearing should the boat take to travel directly to the island? So let's say that this is the island. And the boat is 12 miles west and 15 miles south. Actually, that should be a 12. So the boat is somewhere over here. So that's where the boat is located relative to the island. What bearing should the boat take to travel directly to the island? The boat has to travel in this direction. So we need to find what the angle is at that point. So let's turn this into a right triangle. So this is 12, this is 15. What is the angle theta? So 12 is opposite to the angle and 15 is adjacent to it. So we need to use the tangent function. tangent theta is equal to the opposite side divided by the adjacent side. So the angle theta is going to be the arctangent of 12 divided by 15. And you should get an angle of 38.7 degrees, which is this angle. Now this is north relative to the boat, this is south, this is east. So the bearing is north 38.7 degrees east. So from the north line, he has to travel 38.7 degrees east to get to the island. So this is the bearing. John spots a crocodile directly north from his location. Susan is 500 feet east of John and spots the crocodile at a bearing of north 32 degrees west. How far is John from the crocodile? So let's say the crocodile is right here. And John is at this position. So John spots the crocodile directly due north from his location. Susan is east of John's location. And she's at a distance of 500 feet. So I'm going to write J for John, S for Susan. Now Susan also sees the crocodile. And she spots it at a bearing of north 32 degrees west. So relative to Susan, this is north, and this side is west. So this angle, traveling, starting from the north line, going 32 degrees west, is what we have. Our goal is to find out how far John is from the crocodile. So we need to find the variable y. Now, if this angle is 32, this angle here must be complementary to 32. So it's 90 minus 32, which is 58. So now we can use this triangle and find the value of y. Tangent of 58 degrees is equal to the opposite side, which is y, divided by the adjacent side, which is 500. So if we cross multiply, y is equal to 500 times tangent of 58. Tan 58 is about 1.6. If we multiply by 500, then this will give us the value of y, which is 800. So that's how far John is from the croc. So the croc is 800 feet north of John, or John is 800 feet south of the croc. A boat leaves an island and travels 36 miles at a bearing of north 53 degrees east. Next, the boat makes a 90-degree clockwise turn and travels 15 miles on a bearing of south 37 degrees east. How far is the boat from the island? So let's start with that. Well, first we need to draw the island. So let's say that's the island. And the boat is going to travel 36 miles on a bearing north 53 east. So this is east. So relative to the north line, he's going to travel 53 degrees east from that. Now he can continue straight, but he doesn't. He's going to make a 90-degree turn in a clockwise direction. This is counterclockwise, and this is in the direction of a clock. So he's going to change his course going this way. So this is a right angle. Now this is north from his new position, and this is south. His new bearing is south 37 east. So if this is south and this is east, From the south line, he's going to go 37 east. Therefore, this angle here is 37 degrees. How far is the boat, which is currently in this location, how far is the boat from the island? So we got to find x. Now what we have is a right triangle. And x is basically the hypotenuse of the right triangle. Now over here, then we know this is 36 miles and this is 15. So we got two sides of the right triangle. So we can use the Pythagorean theorem. A squared plus b squared is equal to c squared. So 36 squared plus 15 squared is equal to c squared. 36 squared is 1296. 15 squared is 225. If you add them, you get 1521. And the square root of 1521 is 39. So that's how far the boat is from the island. It's 39 miles from the island. Now we need to find the bearing of the boat from the island. So here's the boat. Here's the island. We need to know what the angle is relative to the north line. So basically, we got to find this angle theta, represented by the red line. Before we could do that, we need to find the angle inside the triangle. That is this angle. And we could use tangent to do so. Tangent theta is equal to the opposite side, which is 15, divided by the hypotenuse. I mean, not the hypotenuse, but the adjacent side, which is 36. So therefore, theta is arctangent 15 divided by 36. So you get an angle of 22.6 degrees. So the bearing, let's say this is the island, and this is north, and this is east. So initially, the boat traveled at an angle of 53 degrees north to east. And then it traveled in this direction, and we got this angle to be 22.6. So here's the boat at this point. So its new bearing of the boat from the island, so basically this line here, has an angle of 53 plus 22.6. So if we add it, that's 75.6. So the bearing is north, 75.6 east. And that's the answer.